Hello and welcome to the booth Simulation Use Case 2, Closed Loop System Simulation for Integration Test and Validation, the model integration on the CarMaker platform. I would like to explain you a bit about how we enabled the CarMaker simulation platform to support this Simulation Use Case 2, to support the standard interfaces and to integrate the models we have in the Z-level project. So we are basically right at the center in this overview, and what were the general requirements for us and for the simulation toolchains? We planned to integrate models from other parties, for example, the vehicle model, sensor models, driving function, and also static and dynamic environment models as described in OpenDrive and OpenScenario. And to share them between different simulation tools in order to enable a flexible and modular simulation architecture to further develop the interfaces between the models and to actually show that they are usable and to demonstrate the feasibility in industry-leading simulation tools such as CarMaker from IPG Automotive. CarMaker itself is a comprehensive simulation platform which can, in theory, support this simulation use case on its own, with its own internal models. So in CarMaker we have road and infrastructure models, we have a dynamic environment, we have driver models, we have a virtual prototype, which is basically the vehicle dynamics, the powertrain, we have sensor models, and we have a middleware framework to integrate an autonomous driving function, the actual system and the test, and several tools around it to enable processes, to enable the integration into development and testing workflows. And now in Z-level we have replaced several of these models, and I would like to show you how this was done. The main tool or the main interface we have used is the Open Simulation interface, as currently being further developed by ASAM. And the Open Simulation interface basically specifies the information flow between various models. It started off as an interface for sensor models and now has been expanded further within the Z-level project. The main idea is to enable the transfer of binary data of any kind, and therefore we use the OC sensor model packaging as a description how to share these serialized data between one model and another. And we have enabled CarMaker to support OSMT, and here you see that we can have input and output for these various quantities for the FMU, such as we indicate where this memory area begins and how large it is. And we can do this for various models here. So this is now within the CarMaker user interface and shows how the user in the end integrates those models. In the backbone of CarMaker we needed to enable the build of the OSI messages, especially OSI ground truths, as this is the beginning of the information flow from this environment simulator, for example, to a sensor model. Here we see basically how the architecture looks like. So we have at the start a scenario description in OpenDrive OpenScenario. We import it into our own formats. We get a road, get a test run in the CarMaker language. We can select this in the CarMaker user interface. We can connect the FNU models, as I said, and we can also set up test automation routines. Then we have a visualization to visualize a running simulation. The actual running simulation is in the CarMaker executable, where we have our standard simulation core, where we connect the FMUs, where we have our Open Simulation interface extension, and where we map the various inputs and outputs of models. And then we have as functional mock-up units the different models from our project partners. And as a specialty, we have the driving function in a Docker. And this is communicating via TCP communication. Basically, it's an OSI network proxy sending out the data to this external driving function. And in the end, we generate results which can then be further processed. This is an overview more in detail, which messages are being transferred between the various modules. I don't think I want to go into the very depth of it. I just want to emphasize that our part mostly was to generate the ground truth data going to the two sensors. Also for simulation use case 3 to generate sensor view and sensor data, such as reflection-based, for example, LiDAR point clouds, and to enable that to go to various sensors. And one further development we have done for OSI was also to include traffic. So we have here in green, in the green colors, messages concerning the dynamic objects, such as we have a pedestrian model, we have a vehicle model, including a driver. So all of the other traffic participants in the scenario can also be controlled via OSI. So we read in the scenario description, and our tool then sends out the various action commands to these external entities. And just as a proof of concept, we have a very basic scenario. We see a pedestrian walking here. We see a truck driving here. All of these are not controlled by CarMaker, but by these external models. And we see that in general, the simulation environment is working. The traffic is driving nicely within the lane. The pedestrian is also walking on the footpath and not interfering with the car. So we demonstrate by this that we can build up these complex simulation environments. We have a flexible and modular simulation architecture. We can integrate any models using Open Simulation Interface. Therefore, we needed to further develop the interfaces, and we have therefore demonstrated that the industry standard simulation tools are feasible to support these this set-level approach of simulating autonomous driving functions. For the outlook, these OSI extensions, which are now set-level proprietary, basically are being transferred to the ASAM project and adapted as standard. The OSI interface will also be integrated in CarMaker as a standard interface, as a standard feature of our products. So this is our main takeaway for IPG Automotive. And I also wanted to add that we have seen by having multiple of these FMUs that the OSI or the protocol itself using protobuf is not optimal for large-scale simulations, as it's quite performance intensive. Therefore, further development of these protocols is necessary, especially when you think about cloud-based simulation. In the end, we want to test millions of scenarios overnight, and therefore our simulation platform must be really performant. The standard solution, the set-level approach with OSI, still lacks a bit of capability, and this could be a good starting point also for ASAM to further develop this standard. Thank you very much for your attention, and enjoy the rest of the other books. Thank you very much.